So my continuing theme of trying to treat you like honor students, and instead of just giving you a bunch of examples, we're going to think through how the questions are designed, right? So for this first one, they're going to give you what? Point. And how are they going to give you a point? A dot on a piece of paper? Coordinates. So they're going to give you an X and a Y. And lies on the graph, so are they going to give you a dot on a line on a graph somewhere? Or they're going to give you an equation? Okay? Because you and I both know that if we draw the graph and locate the point, depending on how careful we are, that point may or may not be on the line, right? And we don't want to rely on our carefulness, do we? I don't want to. So instead, what can we do to see if the point is on the line?
Plug the coordinates in.
Yeah, plug it in, plug it in. Do they still have that commercial, the house deodorant, plug it in, plug it in? Anyway, you're right, I watch too much television. So that's the idea, right? They're going to give you an equation, they're going to give you coordinates, and you're going to say, does it work, basically, right? Okay, good. Now, if we have, what are we going to be given here? What are we going to start with? Equation, right, good. So you're going to be given an equation, and they want you to graph the line by first finding the x-intercept and the y-intercept, and they can draw a line. Okay? And so you find from the equation, to find the x-intercept, what do you have to understand? If you're on the x-axis, you don't go up, you don't go down, you're on the x-axis, so y is 0, right? You don't go up or down, you're on the x-axis. And to find the y-intercept, you don't go left or right, which means x is 0. Now I know some of you love making up rules. And so you'll go, oh, to find the x-intercept, y is 0. To find the y-intercept, x is 0. It's always the other one. I have to memorize that and repeat it over and over and over 10 times. That's a terrible way to learn. Because if you memorize, what happens? You forget or things get mixed up, right? But if you make it visual, if you're on the x-axis, look, y has to be 0, right? If you're on the y-axis, look, x has to be 0. I think that's a better way to learn this. Okay? Okay, of the two, which one's the easiest? The y-intercept, because all you have to do is set x to 0, boom, 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 and you find what? Y is 0. And you get 2 for 1, don't you? Because that's also what? It's also an x-intercept, isn't it? Because if you cross the origin, you're crossing both the x and y axes, right? Then to find the x-intercepts, you're on the x-axis, so y is 0. And then this is much like the question on the quiz, isn't it? Factor the x out, we're left with 9x squared plus 6x plus 1. Factor again, that's why we gave you the factoring worksheet the very first day. Kind of get your brain in gear for factoring. And so then, who else do I add here? Is that the x-intercept or y-intercept? X, so negative 1/3, and y is still 0. Okay? So, if we were to draw this, clearly it would go through the origin. Clearly it would go through negative 1/3, 0. Now, looking at this, what happens when x gets more and more and more positive? It's going to get bigger and bigger and bigger positively, right? So we're thinking something like this, right? It's going to go off forever to the right, but it's got to do what? Cross the origin. Anybody remember anything about this? What's that about? Remember? There's this funky word, multiplicity. Keep that in mind. What happens when x gets more and more negative? It tends to 0. I don't think so, but I could see why you might say that. You think some of the positives and some of the negatives are going to balance each other out, so to speak. But look, this is a negative to the 3rd power. What is that going to be? Negative, and it's to the 3rd power. It's going to be very negative, right? More so than these two. I'd say the 3rd power term dominates the other two. And so I'm thinking, as x gets more and more negative, y is going to get more and more negative. What do you think? And then this idea here means the graph is going to bounce and go back down. The word that you may have heard is multiplicity. Oh yeah. So we solve this algebraically. Let's see. Like we said, to find the y-intercept, that's easy. Let x equal 0. And what happens if x is 0? Doesn't work. Perfect. 0 equals 12, that's nonsense, right? So I don't think that's going to happen. When y equals 0, you finish that. So if y is 0, knocks this guy out, right? And x cubed equals 12. Then I cube root both sides. And x equals plus or minus the cube root of 12, right? A students, catch me. It's not plus or minus. Correct. This is cube root, right? What's a negative times a negative times a negative? Negative. This thing's positive, isn't it? It can only be positive. I want you to always think, not just react. Okay? This is not the times tables. 2 times 3, 6! No. This is 2 times 3. It's 6. A little thought is worth it, don't you think? Now, the other thing, oh, well, there's more to do here. 4 times 3, 4 is perfect. This is 2 cube root of 3, right? 4 is perfect. Got to bring it out. No, because what word is this? Cube root. 4 is a perfect square, but those things, I'm sure, pop into your minds because you've taken some math in your life, right? Okay. Now, do me a favor and rewrite this equation, y equals. Alrighty, so did you get 12 what? minus x cubed over x squared. Well done. So let's go over to our calculator and pop that in. So you have y equals, press that. Now, suggestion is to always use a horizontal fraction bar, not a diagonal one. So what you do is, what color is this F1 up here? Green. So I want to choose that. So I choose the green alpha key, and then I choose the F1 key, which is the y equals. And I get this menu which creates for us fractions. Choose choice 1. And we get a horizontal fraction bar. Then I can have 12, subtract. You know there's the difference between subtracting and the negative sign, yeah? Subtract, x is up here, and then to the third power, we can do caret and 3, which is probably the best way. But if you go to math, there's also a third power in the math menu. Go down, and we go to x. There's already a squared here, but there's also that caret 2 idea that I mentioned earlier, and you can do that. Okay? Enter. Now if we graph it, let's all see the same thing. Let's press zoom, and 6 is standard, right? Zoom in 6. There's our graph. What do you think happens to these two branches of the graph as they get closer and closer to the y-axis? Well, if we get closer and closer to the y-axis, x is getting closer and closer to who? 0. Good. And so up there, probably have this thing called an asymptote, where the graph, the blue graphs, continue to go up there, but they never touch it. Now, this goes up to 10, doesn't it? You want to see higher than that? Go to Window, and higher than that is like the Y max. If you want to make it 100, you could do that. Enter, and then graph it again. And now it's going up to 100. And you get all these crazy lines because they have one line for every number. There's 100 lines there. That's crazy. Go back to Window. If you go to Y scale, the y-axis scale, and I'm going to say, let's mark just every 10 numbers. So that if it goes to 100, yeah, and it marks every 10, it'll look a lot better. What do you think? Yeah? All right, now, we said we have an x-intercept, don't we? Well, look at the graph. We do. So let's do this. Let's go back to setting our window. We don't need to go that high anymore, so the y max, let's say, is back to 10. And graph it again. Okay. Now, one way which is wrong is to press trace and go to the right, go to the right, go to the right. Here it comes. Is that the x-intercept? Almost, right? Except check it out. What should this be if that's the x-intercept? 0. If I go down one more time, or not down, right. Now what happened? Negative. I got past it. I go back to the left. Oh, I passed it again because the setting for each step is set. You can't change it. So trace is not very useful. Here's what we do instead. Second, calc, which is the trace key. But second, calc. What looks interesting there? Intersect's not bad, but that would be when two graphs intersect. Try again. 0. A 0 of a function is when it gives you 0. When y is 0. When it results in 0. So 0 is the x-intercept. Choice 2. What does the bottom of the screen say? Left bound. So go back to the left a bit, anywhere to the left of that x-intercept. I know you're also above, don't worry about that. You're to the left of it, press enter. What does the bottom of the screen say now? Right bound. So go to the right, past it. I know you're below, but you're also to the right of it, aren't you? Enter. You know, some graphs like do zigzag, and they might hit the x-axis more than once. Your calculator can only do one at a time. So you say, which one do you want? Between this and this. Between the left and the right. Now it says what? Guess. And so you say 2.1. Nothing happened. I guessed. Oh, wait. Guess means you go back onto the x-intercept and see what happens. And look at where y is. 0. And here is the x-intercept. Do you think it's perfect? Or do you think more numbers follow this? More numbers follow. Because let's go back here. Who was the x-intercept? Cube root of 12. Let's see. Second clear. What happened to my... I'm not the second. Okay, clear. Maybe that'll work. Nope. So if I do the cube root of 12 and go back to our graph, which I erased. I'm having trouble here, but I think you'll remember the numbers are kind of the same, right? Yeah? Good. All right. So you can see that for us to graph, I have to have y by itself, right? So if I do that here, I have y equals x squared minus x minus 1. I factor the y out, don't I? Who's going to be in parentheses? X minus 12. And then if I get y by itself, I have to divide by this, won't I? So if I go back to my graphing calculator and go to y equals, now what I can do is maybe I'll need this for my other class. So the graph I just put in, I'm going to go onto the equal sign and press enter. Now that equal sign is no longer darkened. It's there. I don't have to type it in again, but it won't show up. So when you do your homework, you can do that, just in case you want to see it again later, but you want to do another problem. You go down to y2, and so how do I make a fraction bar? Alpha f1, choose 1, and we have x. We'll square that, subtract, wrong subtract, Mr. Mori, subtract x, subtract 1, over x, subtract 12, enter, zoom 6 for standard. Does it just touch the x-axis or does it cross it? Heck if we know, right? So here's what we can do. All of this up here is like worthless. So let's take the window and have the top be 1. I don't need anything above that, do I? Graph it again. Oh, it does cross it. How about down here? This is not worth anything. How about if my bottom of my window, y minimum, is negative 1? Now I see two distinct x-intercepts, don't I? And then I go to second, calc, and do 0. Do left and right of one of them, and then guess that one. Start over, do left and right of the other one, and then guess that one. All right?